Good. So before I start, this presentation, if it runs smoothly, will contain a lot of information in capital letters. So I suggest if anything is unclear, do not assume everybody else understood, but please ask. All the others will probably be grateful for it. So raise the hand, interrupt me, whatever. It is better that you ask right away than you wait for a good occasion. So the idea of this presentation is to show you how to run Reflex once you have installed it. And as John Pritchard mentioned yesterday, getting it installed can sometimes be difficult. So let me repeat that if you have problems, you should contact user support at usd-help@eso.org. So once you have installed it, then maybe you installed so many workflows that you lost track of what you have. In which case you can use the command ESO Reflex-L, which will give you a list of all the workflows. And on the left, you see how you can call them, which is usually reasonably short name, and on the right, you see the full path. Now, for this demonstration, I will also use a force workflow, but a slightly different one, namely the one that deals with spectroscopy. So you can see here it's listed, the force spec. So you just type basically ESO Reflex force spec and return. And then you get, unfortunately, a lot of text that you don't really need and that is very confusing when you see it the first time. You see the Kepler window that pops up when you call ESO Reflex the first time. This usually takes a bit longer because it has to perform more checks. So here you see now the force spectroscopy workflow. So let me just enlarge the window a bit. And then I can show you immediately one very useful button. So at the top left, you see first a line, the top line with file, edit, view, etc. And below you see some small buttons. And the third from the left just scales the workflow so that it fits in the window that you provide. Now, I will first try to explain the top part. So the three columns here, workflow instructions, setup directories, global parameters. Then I will briefly explain once more the sequence of steps in the workflow. And then I will finally run the workflow on some data and show you how to use interactive actors, etc. So now let's start with the top part, with the middle. The setup directories, and especially when you're on a small screen, this plus button can be very useful because it allows you to get to a size that you can read. Now the setup directories is where on the one hand the FITS files, the input and output FITS files are stored, and also where the bookkeeping is stored. So in the first line you have something called root data, which is basically a kind of placeholder of where you have all your data, and the way Reflex is installed depends a bit on whether you use the installation script or the RPM, but definitely you have an area somewhere where you have the word data in it, and if you click on it and move it, it suddenly moves even though you didn't want. Now, then the next are two input directories, one for your raw FITS files. So let's say if you download the data from the archive and you use Selector, then for instance you have your science data and the raw calibration frames, if you selected raw calibrations. And those are stored in some directory, and this for instance you can put in here for raw data. Then the next one is calib data. This is a bit confusing. This refers only to the so-called static calibrations. So this would be standard star catalogs with photometric or spectrophotometric standard stars, line catalogs for spectroscopy, things like that. So calibrations that do not necessarily depend on the type of target you observe, but that are always needed for data reduction. When you install the pipelines, they will fill this calib data with the appropriate static calibrations for that pipeline. You may also get them from Selector. If this gets to confusion, Reflex may stop and tell you, I found 2 identical files in 2 different places and I don't know which one to use. In that case, you just have to remove one of the files. Now, normally this is not a problem, so unless you have a good reason not to use the static calibrations delivered with a pipeline, because you have a line list you consider better or you have a better standard star catalog, then change this directory. Otherwise, leave it as it is. If you have good reasons not to use the static calibrations, we would appreciate if you informed us, because this might be of interest also for other users and it may be a way to improve the pipeline. Now, so these 2 are your input directories. Now we come to the output, and you see here the statement that none of the directories under output and working directories should be a subdirectory of the input directories. This is because the way the data are organized, Reflex expects to find, in general, only raw data. There are a few workflows that accept also master calibrations, but by default it expects raw data. And if you mix products in, the whole data organization can get confused. So please keep the input files and the output files separate. They can both be subdirectories of the root data though, no problem, but they should not be subdirectories of one of those 2. So end product still is where Reflex stores the results of a certain processing run. Those have a date stamp. So for instance, today it would be 2020-09-08 and then a time. And below that date stamp, they're organized by file name. This will become clearer when we come to the data organization. And then you have,
excuse me. So you sound very noisy, so quite saturated. Maybe I have the impression that when you move a little bit back from your screen, then it's getting better, or yes, maybe.
Okay, I try to stand a bit back. Is that better?
Say something again.
Is that better? Not convincingly?
No.
Is it now better?
Yes, it's getting better.
Good. Remind me again if it gets worse, because, yeah, I can't hear myself.
Okay, that was good. Thanks.
Good. Okay, so bookkeeping. So this is where it stores all the information of which data were processed, which parameters and which steps, which other products were used to process those data. The log file stores just the ESORex.log. Then the temporary product stores the output of every recipe, so even of the final recipe. And all of these 3 directories, for a given recipe execution, they all have the same timestamp. So once you know the path, for instance, to the temporary products of a certain execution, you know where to look for the bookkeeping files and the logs there. And then there's a bookkeeping database, which is important because there it stores all the information that is needed for the lazy mode, like I reduced this data set with these parameters. So if, let's say, you want to break the lazy mode, you can, for instance, remove or rename this file, and then it will forget everything about what you did previously. If you do it accidentally, it can be a bit annoying. So this is about the setup directories. Is there any question right now? Okay. Then we move to the right, where we have something called global parameters. And some of them show up in every workflow. Some are workflow specific. I think all of those here show up in every workflow. So the first is when one of the recipes fails. You can either decide to stop the whole workflow, because you say, okay, if anything fails, I want to stop and inspect what happened. You can say continue no matter what, which usually means that if you have several data sets and in one of them, one recipe fails, for instance, the wavelength calibration, then the science file will not get reduced, but it will then go on with the next data set. So this is good if you want to process a large amount of data without inspecting everything. Or you set it to ask, in which case a window pops up and asks you, do you want to continue? Do you want to stop? And this is also the default. Erase those means every time you start the workflow, so not after every data set, every time you start the workflow, it first cleans up all the directories. This is good if you're pressed for disk space. It does break the lazy mode. Then we have here something called a FITS viewer. This is when you want to inspect files that are not shown by interactive actors. And unfortunately, in the installation, it just puts a default value, but when it's actually called, it needs the full path. So, wait a minute. So you just double click with the left mouse. You get this window. And you can enter the full path of whatever tool you like to use. And then this will be used by default when we want to inspect files. This global variable determines whether the interactive actors that Wolfram mentioned are active or not. If it's true, they are active, provided this parameter is used inside the actor. In some workflows, some of the interactive windows are switched off by default. So even if you set this to true, not all of them will be used. That's true, for instance, for you with an X shooter, which can be a bit confusing. But the Reflex tutorial describes, I think, how to change that. Then here you have the select dataset method. This is when the data are organized and the data sets are created. Then you can either decide which ones to process, or you can say, set a certain default here, like process everything, only the ones I never reduced before, the ones I did reduce successfully before, failed one, unsuccessfully run before, or the interactive, which allows you to choose and inspect. And then we have the Product Explorer mode. Trigger means it waits until all the data sets have been reduced and pops up then. Enable means it pops up after every data set. And disable means, you guess it, it never shows up. Any question about this?
Please simply use raise hands or type it.
Maybe I should have put a quiz at the end.
A what?
A quiz at the end to see if people are just saturated or if I really made it through. Good.
Yeah.
Workflow instructions. This is basically what I will tell you in the next minutes. So we'll not go into it in detail. The one thing that it mentions here in the beginning is to choose this animate at runtime. This is at the top left, where you have this line with workflow tools, etc. So when you click here, you get this animate at runtime. And this simply means that those recipes that are run, let's scale back. So every time it runs one of those actors, it gets a red boundary. So you see where it is, which can sometimes be encouraging if reduction takes long. So now coming to the workflow itself. Let's see if I can make this a bit bigger. Okay. So, okay, here you have just the initialization, which you have every time, and there's nothing you can do about it. Here you have the possibility to run the Product Explorer that usually comes at the end, namely over here. In the beginning, for instance, if you want to recover what you did before, remind yourself what the success was. By default, this is switched off. So when you right-click on this and click on the Configure Actor, then it tells you, okay, do you want to inspect this, yes or no? And do you want to continue the reduction? And then you can say yes, continue, stop, or ask. Right now, we don't do anything. Here's the data organizer that Wolfram already explained. So here, your FITS data are organized using header keywords like, for instance, the observing mode, the detector, the observation setting like the GRISM or the filter, things like that. And then we have the data set selection. So this is where a window pops up showing you the data sets and allowing you to inspect and select them. Here we have again some initialization, the FITS router. And then here's the sequence, the master bias, the wavelength calibration and flat fielding. On the top, the determination of the response curve. And then finally, everything here is combined in the foresight. So you see, for instance, here the master biases are routed to the wavelength calibration and flat fielding, to the flux response curve and to the signs. And similarly, the output of wavelength calibration and flat fielding is routed to the response determination and to the signs, and then the response curve is handed on to the signs. And then you have this product renamer, you close everything and clean up, and finally the product explorer. Now, the next step is, let's start. So let's again scale back. In order to start, first I want to change the raw data there. So if you click on Browse, a window will open. And then if you click on the directories, and then you also have to click OK. It's not enough that it shows up here. Only when you click OK, it's really updated. So now you press on this little play symbol, and you see this red border. And by intention, I did not put in a lot of data sets, so this is one explanation why it's so fast. So this is the dataset chooser. Let's enlarge it. So what you see here is first 2 datasets in black and 1 in gray. And the 2 datasets in black are ticked because they have never been reduced. If they had been reduced before, there would be either an OK in green or a failed in red. Here you can enter a description. I hope to remember to do it later. And then here, every workflow has a list of keywords that inform you what type of data you're looking at. Usually some way to identify the target. Here, for instance, it tells you which prism was used and which filter, and then also in some way which observing mode. Here, this is multi-object, this is long slit. Now, one of them is gray. Gray means it's incomplete. So some calibration that is mandatory is missing. In this case, it's the arclamp file. So when you click on it, so that it's this blue-gray, and you click down here on Inspect Highlighted, then it opens it. And you see now, here is a little, so here you see first of all the various steps, the bias frame, the calibration, and the flux standard star. And here you see, this is the wavelength calibration and flat fielding, and indeed we have no arclamp frame. In this case, don't bother to try to reduce it, it will fail. Generally, the OCA rules that are used for the organization of the data are set up in a way that a data set is considered incomplete if it will really fail. Then there are also optional calibrations, like for instance in spectroscopy, the flux standard star. There are quite a few science applications that do not need flux calibrated spectra. So there we say this is an optional calibration. Now, let me just check. This is not the one, but this here. For instance, here you have the raw science frame. You have some so-called static calibrations like an extinction table and a grism table with configuration parameters. You have bias files and you have the wavelength calibration and the arclamp frame here, but you do not have a flux standard star. For force, this is considered acceptable. Now let's look a bit deeper. So here you have bias frames, and here you have another bunch of bias frames. And by chance, these are the same frames. So if you just check the first one, you see it's identical frames. This doesn't have to be the case. It could also be a different set of bias frames. And so you see at the top, here we have the science frame. This is the bias for the science frame. Then we have wavelength calibration and flat fielding. In force, this is one recipe. And this again needs bias frames. So this is why here we have another entry for bias. And here you see which draw files will be used, which line catalog, which configuration table. And for the biases, we do not have anything else. Now let's assume you know that the third of the flat fields is garbage. In that case, you can untick it. It will not be used for processing. But be careful. Let's say if you know the third bias frame is garbage, then you have to untick it at every place where it's used. It is not sufficient to untick it just once. Because if you untick it just up here, then it will run this processing, and when it comes to this one, it will notice, oh, it's a different set of files. I haven't processed that before, I need to do it. And then you have all the bias frames in. Here on the right side, you can inspect the header keywords. which basically lists everything you ever wanted or not wanted to know about your header, which can be useful if you want to check, for instance, whether you have really the right chrism, you don't have a filter you didn't want, whatever. You can save this as an ASCII file if you want to inspect it further. Let's select this bed. And for instance, here, you can now also inspect the bias. So if you click on this inspect button, it will open the viewer that you specified before. So now, unfortunately, Reflex is always on top. So here you could, for instance, check that the bias really looks like a decent bias. So now when you're done, you click on continue, and this puts you back to this window. Now, if we inspect the second data set, you see this has, again, bias frames. It has calibration files and the other bias. And here we also have a flux standard star, which again has its bias, has its screen flats and wavelength calibration. And here, for instance, you see a case where different biases come into play. So this bias here is a different from the bias down here because they were observed on different nights. This is not a problem. Reflex keeps track of it. And here we have the next biases. So you see, this is quite complex, and keeping track of all of this is not trivial. So, okay. Now let's start, which means in this dataset chooser window, we click on, oh wait, sorry, let's add a description. So this will just run with the default parameters. This allows us later on to see which reduction we are looking at. So let's click continue, and you see now the bias reduction starts. Here we do not have an interactive window, so nothing else happens. And here we are now at the step that does the master flat fields and the wavelength calibration. So what you see here, first of all, it can be useful to click on this full frame. And for instance, here you see a wavelength calibrated arc lamp frame. You see which arc lamp lines were detected. And when you move the cursor on one of the windows, the so-called tooltips pop up. These are descriptions of what you see and what you should see. So what you should look out for. This can be helpful if you're not familiar with the type of data you're reducing. Then here, for instance, you see the residuals of the wavelength calibration. Here it can be useful to zoom. So on the top, you have this little magnifying glass. When you click on this and go back, then you can, for instance, zoom in and see how big the residuals, for instance, really are. You can also zoom in here. If, for instance, you want to have a closer look, this is just where it detected the various slits from the multi-object spectroscopy. I will not go into more detail what is shown here because this is very force specific and this talk is not about force. So let's say for whatever reason, you're not happy with this. You think, I don't know, too many lines have been detected. So you lower the detection threshold and you click on rerun. This means it will now rerun the recipe, not with the default parameters, but with the parameter I just changed. Okay, looking at the result, I would say this was not a good idea because now it detected also a lot of noise peaks. So you see the residuals are bigger. Here we have suddenly gaps, etc. So I will go back to the original parameter, which was 200. And click again, rerun. So here you have some more buttons. You can disable this window in subsequent ones, which is fine if you're sure that your parameters are perfectly fine for all of your data. If not, I would be careful to do it. And you can say use the parameters above as initial values, which works only for some in the case of force, but I think generally works fine. This means instead of starting with the default parameters, you start with other ones. And then down here you have something called files info. Let's make this bigger again. And here you see now products from this recipe. And when you move down with this bar, you also see the input files. And if you, for instance, double click on this one, then you see how the input flat field looked like, which can be useful. So let's click Rerun, and this should now be fast because now it's using the same parameters as with the first execution. Indeed, so now we are happy. Continue. Since we did not have a flux standard star, it just bypasses the response, and here you have now the science window, which differs definitely from instrument to instrument. In this case, for instance, you could again zoom in and, for instance, check which spectra were found. And then with a middle mouse click, you could have a look at them. They're between the red and the yellow lines. So for now, let's just continue. So here is the process window. Here it always tells you where it is in the processing. And here's your result window. So this tells you, for instance, where you find it in the end. This here, no? Okay, this is the date timestamp that I mentioned, and then it's followed by the name of the data set. Okay, here we have again the wavelength and flat field actor. This looks a bit different because it's a different observing mode. It's one long slit instead of many short ones. For now, we just continue with this. And now you see it runs a second time. And while this looks extremely similar, it is now the calibration for the standard star, which for friends distinguished by these bright lines here. Nevertheless, again, we just continue. And now you see it goes to the response. It shows, for instance, here the reduced standard star spectrum, the derived response, and the standard star flex calibrated with its own response compared to the reference data. So again, we just continue. And here we have the final result. And we continue again. So now we have the Product Explorer. And up here, for instance, you can select what to show. For instance, if you want only to see the successful one or only the unsuccessful ones, by default, it's all. And by default, it also shows all executions. This can be a bit confusing if you have been playing around a lot. So if you want to see just the last one, you click down here, which changes nothing in this case, but it may be helpful later. Now, if you want to inspect your files, you click on this little handle, and here it shows which execution we are talking about. And you remember this description default that I put in the beginning. And when you click then on this, you see all the products that were created. So let's, for instance, look for this one. And then you click on it. And then when you use the right mouse button, you get a menu. And if you click, for instance, Inspect Generic, then it will use the inspection tool that you specified in the workflow. Okay, you see that you don't see a lot. So, okay, you see even less, sorry. So this, unfortunately, was not a good choice because it's a frame with basically nothing in it. This is not really uncommon for forced spectroscopy, but still not a good choice. So let's have a look. Sorry. If we see something more in the other frame, so you click on the execution, and we again want to see the science frame and click Inspect Generic. And here at least you see a little bit more. So here you see the spectra of the individual slits, which are now aligned in wavelength. So when you're done with this and you say, okay, I'm more or less happy, you click Continue. One very useful feature, if the workflow you're using does not have interactive windows, is here again you can inspect all the files that contributed to the final product. And then when you go here, you see which raw files contributed. So if you do not have interactive actors, this means your workflow just runs through and presents you at the end with these results. This is a way to inspect it. Unfortunately, it's not as comfortable as the rerun. So let's click continue. So we are done. Now, let's say I want to change something for the whole workflow. So for instance, I want to change the way the sky is subtracted. In this case, for an interactive actor, I go to the actor and I right click and I click on configure actor. And here you see now a list of parameters that you can change, recipe parameters. And those are exactly the same ones that are offered to you in the interactive window. So for instance, here I want to change this to true. And I want to change this to false. Then you click commit. So now let's assume you want to change a recipe parameter that is not offered. In that case, it's a bit more cumbersome. So you first click on open actor. So not configure, but open. It's again right mouse click on open, and a new window pops up. And usually you see just parts, so you use again this very useful button up here. Okay, moderately useful. So, and then you look for this symbol. This one, which is here called for science. This is the so-called recipe executor. And again, you right click and now you do configure actor. And now you're, let's say, on a lower level, but you can access all parameters this recipe has. And what is noted here with port are those that are offered by the interactive window, and anything else you can change. So for instance, I want to change down here that so-called IDPs are created. This is a special output format. Instead of image-like data, it produces fits tables. And again, you have to click commit. And here, for instance, if you remember, you see the recipe failure mode is defined by this global variable. The lazy mode is switched on. Here you see the recipe that you cannot change. And some more information. You click commit, and this one you can just close. So now start again, and now I want, for instance, to call this IDP, and I want to rerun the ones I already successfully reduced. So when I go to this filter and I click on reduced, you see it ticks those two. And now I click continue, and now you see it's very fast. Here it basically takes time to open the interactive window. You do not want to change anything here. There was no flux standard star. And now we see, okay, yes, we have again a science product. At least for me, it's impossible to judge whether this is better than the one we saw 10 minutes ago. So for now, I'm puzzled because I thought I changed exactly that. Okay, so instead, let's rerun. Okay, we can continue. Strange. I think I managed to do something I wasn't planning to do. So you know that this is really a live demonstration and something I taped and fiddled with. So now we are back at the Product Explorer. So now when you click on the handle, you see there were two executions and both were okay. If I limit this now to the last execution, you see it's just one, the second one. So let's go back to all. And So now let's say up here, I want to inspect what the differences were. So this is the one where I asked for the IDP products. And here you see there are 2 additional files which weren't there before. So let's, for instance, go here. You don't see those files, the ones with the IDP in their name. But for now, what I want to see is just to inspect the sky subtracted frame. So this is from the second reduction. This is from the first. And once we move the various reflex windows out of the way, we can even see the result, which I admit does not look too impressive when you first look, but what I want to focus you on is this part on the right. So here we have reasonably bright skylines, and you see in the first default reduction, here the skyline is still present, rather bright, and here we have some remnants, whereas in the second reduction, it's at least a lot fainter. And the other ones are almost unseen. The cuts up here are the same in both. So this is where the Product Explorer can be very useful when you run the processing with different parameters and want to compare the results in the end. You cannot, well, you can do this file by file during an interactive workflow, but this can be more useful because you can compare them all in one go. So here we are done. So let's click continue. Okay, now, finally, as I said, there may be times when you want to process a large amount of data without wanting to fiddle right away. Maybe you just want to process them to see, okay, what do I get if I just use the default parameters? What do I want to change? And there are basically 2 ways to do that. One is to use this workflow and change the recipe failure mode to continue and change the global plot interactivity to false. And now let's say I want to keep this. So I click on File on the top left. And I do not use Save As. Save As saves it in a format that you could use again, but that you can, for instance, not use on a different computer that you cannot send to anyone. So instead, use Export As and then XML, because that's the original file. It will always give you this error, or this warning, not an error. You click OK. And then you just call it batch, and you click Save. And then you wait a little time. And here you see you now have the new one that's called batch. I recommend if you do that you close the original one. And then it asks about this and that you can discard. Because otherwise, at least I managed to confuse myself when suddenly I have 5 different workflows and maybe 3 of them have the same name because I kept saving in between. So basically try to close things that you're done with so that you're not confused, not that you run suddenly a workflow you didn't want to run before. And you see now this one has the new values I have set. Here it has continue and here it has false. Anything else is the same, so I still have the same raw data do. It also remembers that I had reduced the data. So let's say I use the reduced and now we do the continue. But for instance, what does not get copied is this animated runtime that I would have had to set again. Since we are in lazy mode, it was very fast because it basically just copied the output. And okay, we didn't have a failure, so that was not a problem, but none of the interactive windows popped up, which can be very useful if you already are where you want to be. So let's move this one out of the way. Now, the other way to run this is to type ESO Reflex minus n before the workflow name. And now let's say, and this is the original workflow. So let's see what happens now. So it's not the one where I switched off the interactive windows. And it's also not the one where I set the recipe failure mode to continue. This is about the data organizer. And now it's already processing, although you don't see it. And you notice it does not pop up those progress windows. So do not get a little window that tells you, I'm processing now file 10 out of 320. Okay, and now let's just freeze it. You see this line that was before in the window of its own is now just here on this line. Oh, I just remember, sorry. This is of course now running on the normal demo data, which means it has to really process everything, which will take quite a bit of time. So while we wait for this, and as this was the last thing I wanted to present, are there any questions?
Yes, there was one question from Lowell. But John has answered it, but I will read it. I will read it anyhow to everyone, because not everyone might be monitoring the chat. So Lowell was asking, if you save an XML version that you've changed, how do you then use it in a brand new restarted ESO Reflex session?
Okay, that I can demonstrate, even if John has already answered it. So let's get out of this one with exit. No, we do not want. Now, so far, so one possibility is, I could call it like this, but not with an N. So let's do it simple. So here's the list of all the workflows I have, and here you see the newly created 4-spec batch. So one possibility is to call it like this. So basically just put the name of the new workflow.
Yes, this is also what John typed in the chat window.
At least we agree.
Yes, he agrees.
Okay, the other possibility, if we get out of here, is you just type ESO Reflex. Because, for instance, maybe you didn't save it in the directories of the tree, and I'm not sure it really checks everything. And then you click here on File and Open. So by default, this opens where the workflows are stored. But if, for instance, you put it in your home directory, which I think I didn't, so I don't have anything to demonstrate. But then if there were an XML file somewhere here, if this were an XML file, you would click on it and you would say Open, and then it would open the workflow. This is if, as I said, you put your workflow somewhere else. So, any other question?
I don't see anything right now. Lowell says thanks to both of you. There's one question from Henri Buffin. The forced pipeline you showed does not seem to remove cosmics. Is there a parameter to allow this?
Yes, there is a parameter in the science recipe. I think it's just called cosmics, and it usually does a reasonably good job, but it sometimes manages to distort the line profile. So if one wants to use that, I recommend to run it with and without that and then compare the results.
Okay, I presume that answers it. Yes, thanks. Actually, I have a question which is more a general thing, and maybe also for Wolfram and you, I don't know. So what is the prospect of running all the ESO Reflex not on your own machine, but on an ESO machine, so that the user can do it remotely? Because I know that many people are struggling with installing the pipelines, right? I mean, the ESO Reflex, and I myself, I'm also struggled with it. So it would be great if users can use actually the pipelines on ESO machines and just do it remotely. Is anything like this foreseen?
I don't know. This is a question for Wolfram.
Is he still around? Wolfram, are you still there?
I would hope so. You're muted.
You're unmuted.
The development of new features in Reflex actually stopped because we eventually, in some years, we want to replace it with a new system. So it's not there, and it will never be there in Reflex.
Okay, good. Thanks. Then we have another question from the participants, from Thibaut. When I installed Reflex, I had a directory in my home called Kepler data. Can I move this directory in a different one?
You can move it or you can even remove it. Actually, whenever you install new versions of pipelines, new versions of Reflex, you should remove the .kepler there. So this is a directory with small letters, .kepler. Kepler data, I think, usually does not cause problems, but .kepler can give you trouble when you install new versions. Otherwise, you can move those wherever you want.
Yes, you can remove it, but of course it will be then recreated at the same place. And there's no possibility to actually change where to create this file, this directory.
At the moment, I do not see any new questions or raise hands. Doch, wait, there's something coming. From Pradrip Karmaka. I have installed ESO Reflex. Now, is it possible to install the force workflow?
In principle, yes. Now, the problem is when you have already installed ESO Reflex, you probably also installed already some pipelines. And whenever you install a new pipeline, the first thing it does is it cleans out. So it basically removes everything that was installed from pipelines before and puts itself there. So what I would recommend, what might be the most straightforward way, unless you had trouble installing ESO Reflex, is just to install it again and select, in addition to the pipelines you selected before, the force one as well. Installing the pipeline later on is possible, but a bit tricky. So if you really need it, I suggest we talk about this offline, because that goes way too far explaining this verbally only.
Well, what Sabine just stated, it assumes that you use the installation script.
Yeah, sorry,
I mean,
true.
If you use the RPMs or the MAC there's no problem to install it in any order because the dependencies are resolved automatically. But the installation script, as Sabine already said, you can rerun it, but it will wipe out the previous installed version and reinstall it.
Good. But as you say, Sabine, is probably also a matter of, I mean, how exactly everything was done. And if Pandit wants to talk about it in more detail, then he can contact you on the chat, right? On the private chat.
For instance.
Okay, great. Thanks.